Hey, we got another integral on the board today. We have something here from MIT 2011. We have the integral of x to the x times ln x plus 1 dx. Okay, the first thing I want to deal with here is this x to the x situation. We don't really want x in the base here. What I'm going to do is we're going to just use this formula that's really useful. We can write x as e to the ln x, and then, but what we really want is x to the x. So if we raise both sides to an x power, okay, we'll have e to the ln x to the x. We can just distribute this in by the property of exponents, and then we can write this here as ex ln x. So next what I can do, now that we have this, I can just bring this and substitute this back. We have this equivalent expression, so I'll just substitute that right back in there. So rewriting this, we're going to have ex ln x plus 1 dx. And then from here, this thing is actually looking pretty suspicious. If we were to distribute this out, now we could have it as two integrals, right? And we got the similarity of having like the ln x here. It's making me think that we could look at the derivative. This is probably the reverse product rule, and what we can do is let's just look at what is the derivative of this thing going to be. So the first part of the derivative with e is just going to be ex ln x, but we're going to need the chain rule. We're going to need the derivative of this part. So what we'll do, we'll take derivative of the first part, so the derivative of x is 1 times ln x plus, we'll just have our x, and the derivative of the second part, which is going to be derivative of ln x, is 1 over x. And then a quick cleanup, these x's are going to cancel, and when we rewrite this, we're going to have ex ln x plus 1. What you'll notice is we took the derivative of ex ln x and we got back our integral. This here is exactly this. So that means that basically our solution is this. But what we're going to do is, just to finish this off, we can rewrite it. Now remember, this is the same thing as x to the x. So actually, for our final solution, we could do it we could leave it in this form. But I think to be nice and to match the MIT solution, we'll write our final solution as x to the x plus c. That's it. Good problem today. Thanks everyone for watching. Have a good day.